Okay. Okay. Mike, so Steve, I think is familiar with the tool set. I think, isn't it, Steve? You have used our tools like GC and the thread and Heap. You have used in the past, Steve?
Yeah, I'm just using the free service right now, so I don't get any of like the
Okay.
the recommendations and stuff like
Yeah.
that. Yes.
But do you get have you used a GC log analyzer, thread analyzer, and Heap, all the three tools, or just one of them, or what is
I
it?
have. I've used all three.
Okay, very good, very good. Thank you. Okay, okay. So, friends, I just want to show you. So this is a thread dump analysis tool, fastThread. In fact, I chose this dump file because this is a problem that happened with the Cassandra database, NoSQL database with one customer site. Okay. See, what has happened was, it's a very major travel application, this one. So you see their application was connecting with Cassandra database, and all of a sudden it started, the thread count started to go high, like a 3,000 plus. In average day, it was only 400 or something, but it became like a 3,200. When they took the thread dump and they uploaded to the tool, to our tool, see the tool, if you are a paying member, you will start to see what are the problems reported at the top. So what it is reporting, here you can see, there is like a 2,319 threads are all in a runnable stack trace, and they have the same stack trace. It is reporting. So if that is the case, we find some anomaly, then we'll report it as a flag. We'll flag it as an error and we report it here. So what has happened was, apparently one of the node in the Cassandra, it ran out of disk space, due to which any new connection that was going into that node, whenever the connection was released, so for every new call that was going in, a new thread got stuck there. So the thread count started building up huge, a number of thread counts started building up, and then they got this out of memory error, unable to create new native thread. The moment they took it and put it, then they figured out, oh, it is going to this node, it ran out of disk space. Once they allocated sufficient disk space, then the problem went away. Okay, so here, see, we have this lot of information. We show a flame graph, all those informations are here. Just with this is just a thread dump analysis. To do this, what you have to do is you have to manually capture the thread dump and then come to this tool and then upload it, and then you'll see the result. Okay, so there is a manual element here, but I want to show the little bit of power of yCrash. Okay, so here, friends, let me, what I will do, okay, see here now, okay, this is the yCrash dashboard. Can you see, guys? See the screen?
Yes.
Yeah. So this is a yCrash dashboard. So yCrash dashboard, here I can see, say you are supporting data stacks, which is the Cassandra team. You support multiple customers. So you can have all the customers' incidents reported and visible for you in one dashboard. See, I can see if you're supporting Facebook, Intune, all those things can be shown here. How many incidents happened on this month? If I'm going to go to the previous previous month, in December, how many incidents happened? I can see. So like this, all the historical crashes are now archived for you and available for you. So if you want to go back in time and do some references, it's all available for you right here. So now let me click on one of the report. So here, this happened with, say, with one customer. It's saying the CCBS is the name of that customer. And here what will happen is, here is the kind of the summary page. You'll see all the errors that have happened is going to be reported here for this incident. If you see on the left panel, here you will see the GC log analysis of that application when the problem happened is showing up to you, is here, the GC log analysis. So this is coming from our underlying GC-EC engine or GC log analyzer engine. And then here is the thread analysis, right? Here you're going to see all the thread analysis. The thread report analysis is visible to you. And if you want to do the heap dump analysis, here you can see it here. Everything is coming.
This is a result of yCrash?
Yes, this is the result of yCrash. Yes.
So was this, yeah, is this generated by, is this like a manual click, or is it they set some threshold for a system resources and it generates this?
Okay.
Yeah.
That's a very good question. See, what you can do is you can set some thresholds, saying if it goes beyond this 80% or 90%, then or even I will talk about micrometrics. What we do, what we call as a micrometric monitoring. In the micrometric monitoring, we can predict and forecast even before the problem happens. I will talk about it in a couple of minutes. But going to your question, yes, you can set threshold. Answer is yes. And if thresholds are breached, then this gets triggered. Or other option is we also give you on-demand mode. So let me explain the yCrash architecture a little bit so that it will make sense. This question. So what is it? We give an agent. So this agent has to be installed on the production servers, on the production OS. So once this agent is installed, you can trigger this agent in three modes. What are those three modes? See, the first mode is called as on-demand mode. In this on-demand mode, you just give the agent is basically a Golang script. It's nothing more than a script. It's just a script. You run the script and then you give the process ID. When you give this process ID, there's a process which is sick. When you trigger like this agent is going to capture 360-degree data. See, what do I mean by 360-degree data? Like here, it's going to capture the garbage collection log, thread dump, heap dump, netstat, vmstat, iostat, top-h, ps, disk usage, lsof, dmessage. It's going to capture all those data, and then it's going to transmit. Once the data is captured, then it will be transmitted to the yCrash server. See, the agent is going to transmit to the yCrash server. And the yCrash server analyzes, and then it reports you. This is the analysis report. What you are seeing. So this is one way to run. Okay. So and then the second way to run is called as what we call as a micrometric monitoring mode. So in this mode, in the micrometric monitoring mode, you will not give any particular process ID. You'll just run it. When you run this, the yCrash agent runs in the background always, 24/7. It runs 24/7. Whereas in this on-demand mode, it doesn't run always. When you trigger, it runs and then it dies down. It collects the data for roughly 1 minute. Within 1 minute, it captures all the data, ships the data to the server, and then it dies down. Then it's not running. In this micrometric mode, this process is always running. When this process is always running, it keeps sending the samples of data to yCrash server. And there, the yCrash server has intelligence. What it does is it monitors the micrometrics. All the traditional monitoring tool, they only look at the macrometrics, CPU time, response time, and then the memory. That's what we look. But what we look is micrometric. So let me explain what this micrometric means. So okay. This is an heap usage graph of a very healthy JVM. You see a full GC happening, and then the heap dropping all the way to the bottom. A full GC happening, a heap drop all the way to the bottom. You see this beautiful sawtooth pattern. And the memory drops all the way to the bottom where it started off. But take a look at this one, my friends. Here, you can see, even though the full GCs are happening, this JVM started out at 200 MB. But as time goes by, even the full GC happens, it's not dropping all the way to the bottom here. You see? It's slowly climbing up.
Like a leak.
Yeah, there is an acute memory leak here. It's a possibility. Very highly likely possibility. But this is a scary picture and very interesting picture. When you see this happening, you see this full GC is running repeatedly again and again and again and again and again. The memory is not dropping. This means this application is toasted. It's basically pretty much toasted. It's only running garbage collection and it's not reclaiming anything. Your CPU is going to max out to 90%, 100%, and just going to remain there. But here is what is interesting. Look at this. Your repeated full GC starts here right around 8 AM. But your out of memory error happens only at 30-40 minutes later. what we sample is basically one of the metric what we sample is GC throughput percentage. That is one of our micrometric that we monitor. GC throughput percentage. So during all these healthy good time, your GC throughput might be like a 99%, 98%. It will have a very good throughput percentage. But right when it enters this danger zone, the throughput will start to degrade. From 98%, it will start to go to 95, 90, 85. So when it starts to degrade, immediately what we will do is, when we run in the micrometric mode, the agent now triggers the process which is sick. And then it captures the 360-degree data and sends the sample to the yCrash server for analysis. Okay? And I understand you since you are a data stack, you support Apache Cassandra, you don't have control on your agents, right? You cannot, your customers will not let you to send the data to the yCrash server on your site. I understand that there is a security issue.
Probably
not. Huh?
Probably not.
Yeah. So just to mitigate this, just to address this, what you can do is there is an option that you can give the script to your yCrash to your customers, this YC script. Like, see, I'll show you a real demo. Okay. After doing this, you just say you can pass this argument called as onlyCapture. When you pass this flag onlyCapture, then what the agent will do is the agent will capture all the 360-degree data, all the data that I showed here, GC log, thread dump, heap dump, all these data, and then it will build a zip file, an archive file, and then it will drop it on the local disk of the customer server. Then the customer can take the zip file and send it to you. Once you get the zip file, what you can do is in the yCrash, on the yCrash dashboard, there is a way to upload all the input manually. So you can upload when you upload manually, then the yCrash analyzes all the data and generates a root cause analysis report for you.
So real quick, so this zip file that it's creating, it doesn't just have a report in it; it actually has the dumps in it as well.
Correct. It already yes.
Some of these heaps are enormous.
Correct. Yes.
What kind of I guess compression and what are some?
Okay. We right now just do the zip file, which makes it fairly small. But also you have an option, like you can configure and say I don't want heap dump. You can say that. You can just say I want only all other data other than heap dump. But for heap dump, other data are very small.
Yeah.
So you can pass flags based on that. You can disable capturing heap dump. Okay.
Gotcha.
Okay. Yeah. So once you have this dump file, then you can upload it here. And my friends, since you are in support, that's very near and dear to me. Field. See, what happens is a lot of time customer says something and the reality is something different.
Right.
I have seen it. They might say Cassandra is having a problem, but actually maybe it may not be a Cassandra. There is some other kernel job might be chewing up the CPU. Or there could be some other, their own native script might be chewing up the CPU. We don't know those things. But when we capture this 360-degree data, right? Let's go back here. When we capture this 360-degree data, here we are reporting you all the processes that is running on that device at that moment when it ran. Say if any one of the processes is consuming iCPU, then we flag it as error. Other day, one major customer, there was some other Linux. There is something called as a journal CT process. It was taking like a 95% CPU.
Yeah.
It was a system process, and it was taking up CPU. But the customers were saying it is your application is a problem. No, it was their kernel which was running out of patch that was causing it. And now when they put it here, immediately they were able to what they weren't able to solve for 2 to 3 weeks. Once they uploaded it, we flagged it as an error. Then they got back to them saying, then they acknowledge, yeah, this is a problem. And sometimes The outage could happen because of lack of disk space on that node. See, here we report all the disk, all the file mounts, how much it is used. If it is more than this one, then we flag it as an error. Right? And then we also look at the network statistics, whether is it being overloaded, whether there are too many connections in the established state or in the closed wait state and not closing down, whether timeout settings are there or not. We do those things. But now let me show you one real demo, the power of marrying the system data with the application data. Okay. See, let me come back here. See, now I'm going to launch an application called as a buggy app, right? So this is an app that we have developed. When you run this app, it will simulate different types of problems. You can say problem CPU. When you say this problem, when you pass problem CPU as argument, then this buggy app will start to chew up the CPU on the device. Okay. So now let me fire this. Okay. I'm firing it. Now when I do the top command on this machine, you can see, you can see the CPU is at 100% here. I did a top. It is this process, okay? Just to tell you that this is the process we launch is consuming the iCPU. So now what we will do, in this instance, let's fire a yCrash agent, okay? I'm going to get for the troubled process is 922. This is the pin. So what I'm going to do is I'm going to say yc minus c, the config.yaml file. This is the configuration. Then say minus p 922. Okay. When I do this, now the agent now captures the 360-degree data. It's going to capture all the 360-degree data and then it's going to report it to the yCrash server. So here, let's look at this. So this is the calendar.
So we'll have this agent running even in the on-demand.
Sorry, sir. What is the question?
We'll have the agent will already be running even in the on-demand case.
No. In on-demand case, no. Agent is dormant.
Gotcha.
Agent is never running in on-demand case. No. It runs, it captures the data, and then it shuts down. It dies down.
Gotcha.
It will die down. Okay. Okay. So now the agent is running. See, so far on January 15th, 73 incidents have been reported across all my portfolio of my applications. I can see that here. So now this is running. Let it run. It's going to, it ran. See, it took less than a minute. It transmitted all the data, and now the data is now visible, is now available here. See, now you see 73 incidents here, right? Today, I'm refreshing it. Okay, so here I got that incident, the buggy app, which I ran just now, is coming here. See, here it's giving me the overall CPU utilization of this process is this much. And then here is the problem. Showing me right away, this is the problem. It is showing me 6 threads are looping on this line of code. It's able to say pinpoint, this is the line of code. Let me click on this. See, here it says our machine learning algorithms have detected the problem in your application which causes high CPU consumption. And look at this. This thread dump has multiple snapshot of information. One snapshot of information is called as a CPU and memory. See, here we are able to give you a thread level, a very granular level. This thread number 5 is consuming 33% of CPU. And it is working on this line of code. And we are able to say...
So this is probably some combination of the top-H and the
yes.
JStack. Or...
Exactly.
Now, are you taking JStack or are you so, quick question, if they don't have JDK installed, will it do something like a kill 3? How does it get the thread dump?
Okay. See, that's a good question, what you're asking. See, look at this. So, capturing the critical artifacts. Say for capturing the GC logs, we make multiple attempts. The agent makes multiple attempts. Say first it tries to look for this property, whether this property is configured in the JVM. Mm-hmm. If not, this is the property used in the JDK 8 for writing the log file. And this is the property used in starting from Java 9, JDK 9. If both of them are not present, then what we will do is we use this tool called JStat to capture. But then sometimes what happens is your customer might have their own native scripts to capture the GC log or thread dump. They can trigger that. So we give that as an option. These are all the options you can configure to the agent in the YAML file. You say this is the script that traditionally used for capturing the, then you can give this. Then we trigger this script to capture the GC log. We do the same for thread dump. So for JStack, we do JStack, and if it doesn't work, we JStack -F, the forced option. And then we also use this capture command. We do those kind of stuff. We try multiple attempts to capture it.
Okay, great.
Okay, so now coming back. So my friend, you have precisely pinpointed. The thread dump only contains the thread stack. It doesn't contain how much CPU and memory that each thread is using. As you rightly pointed out, that the tool, the top-h option, -P, and if you give the PID, that will tell you all the threads that is running on that process and how much CPU and memory that each process is taking. So we capture the top-h. We take the stack trace from the thread dump. We marry the data. And now we are able to give you this very powerful report.
Right.
Saying granularly, then this is pinpointed. This is the guy, the culprit guy. Like this, we do several more places where we do this marriages. See, what happens is sometimes your GC wouldn't function because if some other process is chewing up the CPU. We marry all those things and we present you this kind of the very powerful report. Okay. So, any questions so far on this?
One quick question. Do you do anything on heap allocation? So have you heard of the T-top tool?
T-top?
Yes, there's a T-top tool. So right now we've seen CPU, we've seen memory, but in place memory. There's a T-top tool which will actually give you a metric on heap allocations per second. So per thread, it will say, okay, what thread? And if you don't, maybe it's something you can incorporate in the tool in the future. But it's really useful for us for young gen GC pauses. Okay. So you see your what you described before is probably older gen GC pauses. So stop the world type. Right. Heap builds up and then we deallocate everything. For young gen GC pauses, you've got stuff constantly added and repeatedly removed from the younger generation. Okay. And that causes a different type of GC pause, especially with G1 GC. T-top is a tool, and it's out there. It's a jar. I'm not sure. I believe it's open source, but we've incorporated it into Cassandra as well. Okay. But it will tell you. You run it over some time. You take a sample, and it will give you. Okay, for example, core thread 1 allocated 300 megs to the heap per second, and that's going to be
by thread. That's very interesting.
Yeah, it's very interesting. Very useful for young gen GC pauses.
Okay. Very good, sir. So I will take a look at it, and actually, I will take a look at it. Okay.
Yeah, I can email that to you actually.
No worries. T-top. We will definitely look at that. And then now coming back, see. Here we have the GC analysis, we have thread analysis, and when it comes to heap dump analysis, see, I will be honest, when it comes to GC log analysis, our tool is the best tool in GC log analysis. And then when it comes to thread dump analysis, our tool is the best tool to do thread dump analysis today. But when it comes to heap dump analysis, I will admit that Eclipse Mat is the best tool for that, especially when you are going to do the large size heap dump analysis. So they're phenomenal, very good.
I was just going to ask, how large can a heap be to upload here?
For here?
Yeah.
This one? You can upload any size of heap dump, but you just need to allocate it sufficient memory for it to process.
What about in the case of I think he's asking about in the case of the yCrash, so it goes to your dedicated server automatically?
The same. We just want to allocate enough XMX for our yCrash server. In a launch script of yCrash, you want to allocate sufficient heap to process it. Okay?
Yeah, I seriously doubt. I'm not surprised on this part. Mat itself is very complex. It's put a lot of work into it. Has a lot of features.
Yeah.
Yeah.
Correct. See, so we get mixed opinions. Some people prefer us, some people prefer Mac. So what we have done is, Mat is an open source tool, so we integrated it with us. So if you look at here, you're going to see the heap dump analysis. You say some people, they say, we don't like heap hero report at all. We want to only use Eclipse Mat. In that case, what they can do, they can configure Mat as their parsing engine. When they configure, so they have an option to toggle to Eclipse Mat report. So when they toggle, here you are going to see the Eclipse Mat report produced by Eclipse Mat on the UI GUI. Right here coming to you. Right?
Yeah. And worst case, it's uploading the heap dump to us, and we could just plug it into Mat ourselves if we had to. Yeah.
Yes, correct. And then one more advantage, Mike and Steve, that I want to point out. See, one of the challenge with these dump files are it's very big in size to keep floating, attaching in a Jira ticket, or sending it to your fellow development team to debug. All those things is a little bit chaos. Whereas now, it's just a matter of cut copying the URL and putting it in the email to your development team or to your QA team to debug, or put it in a Jira ticket. That's it. You don't have to keep shipping the dumps all the way around. And also, the heap dump tends to contain very sensitive information. So we don't want to be shipping it around. Rather, if you're here, yCrash gives you a secure way to do the analysis. It's secure because what happens is your data flows from all the agents, and then it's now in yCrash server. That's it. The data does not leave outside the network, outside even the yCrash server. It just remains here. So it's not going to other developer machines. So you give your heap dump to a support engineer. You give the heap dump to a developer, to a QA engineer. Are they deleting the heap dump after using it? We don't know that. And so in this case, your dump resides in one place. That's it. And then another thing, the beauty is, with respect to security, the dump file tends to contain sensitive information. So if you want to mask, you can also mask the data. You can just say, I want to make only last few digits visible. Because the heap dump tends to show you the numbers even during analysis. You can say, I want to mask and show only last 20% of the data, 80%, then only last 20% of data is going to be visible to them. Right? And then there are a few more features are available. Say, I want to search historically all the crashes that has happened in my applications. Say, I want to, for this customer, what all incidents have happened in the past. I can see on September month, 14 incidents happened. On this month, 9 incidents. So you have this kind of a summary. And from here, if you can click and see and go to the report for that customer, or you can search by your host name, or you can do those search. And if you want to export them as a report and send it to the management, you can do that, right? When you can click for this one, you can do that. And then when you buy yCrash, you get all the other 3 tools also bundled within that. You see from here, if you want to manually do the analysis, individual analysis, GCEC report is there.
Okay.
See, and then even...
And this will be run locally, and we won't have any like limits on it, right? The file size.
Yes, exactly. And then, my friends, what we are doing now is, with yCrash, if you see, if you have seen here in the earlier yCrash report, basically, this is nothing but, this process is nothing but a cool visualization of your top output. So you say if you want to visualize your top output, it may not be you guys sound very sophisticated, you have long experience, but let's say this is a top output. You can just copy and then put it here. You just want to do that, and when you do that, we analyze, and then we tell you the problems that we detect. Or we are saying, oh, the system time is higher than the very high. System time is more than the user time. We find these kind of problems, and then we give you a better visualization, and warnings. We do like a 20-30 different types of warnings we check, and then we report it to you, and we also give you kind of high-level tips how to solve them, kind of stuff.
And
So,
this one's only available on yCrash, correct?
yeah.
Quick question. So how do we say we did do this and we have a customer running their own cluster and say 3 or 4 servers, and we want to get this out to them? What kind of artifacts do they need to download and install, and what does that all look like?
Very simple, my friend. Very, very simple. Say, if you want to just give them, if you just want to give for your customer, you just give them an agent. You don't need to give the entire thing. Agent is just one single binary file. That's it, nothing more. See, the agent is just basically a 8 meg file. It's a shell script, basically. That's it. No other thing you have to give. And if you want to have the yCrash server up and running, what we give you is just one zip file. The installation is very trivial.
Mm-hmm. And we would install this on some local server?
Yeah, they can install on some local server. See, look at it. They just need to have Java 8 or anything above version, and then they just download our yCrash, and then unzip it, and then put our license certificate. That's it there, and then they just launch. Nothing else is needed. Unzip, drop the license key, and then start the server. The server is up.
Would that typically be something we would maintain, or that's something be on the customer side?
See, that is a process model that you want to work it out, how you want to do that, right?
I mean, the server would live on their site, so it would probably be something that they work out, right?
See, so it sounds like.
Yeah, see, I don't want to mention in this recorded line, there is a very major customer who is in the kind of your kind of business model. That is, their software runs on the customer premise. So they don't, so it runs on a different premise. So what they do is, they use this script, Golang script, to run it in the, see, let's do this, okay? So I can do this, onlyCapture. When I do this, it captures the zip file. That's what they do. It captures the zip file, and then they send the zip file to you. And now with this zip file, you can now upload it to your yCrash cluster, and then debug it, and then get back to them. Right? This is one model that you can consider doing this.
So they don't necessarily need a server, right? We could have the yCrash gather everything, upload to us. We process it on our yCrash.
Correct. Yes. This might be one good way. Like, you just give them the yCrash binary, the shell script, and then just say, run this script whenever the problem happens. This script will capture you 360-degree data, and now the generated zip file can be sent to you. And once you get it, you upload it, and then you do the analysis. Okay. So yeah. So it is very simple to get it up and running.
So with the yCrash, how does the licensing work on this?
Okay. So yeah, Mike, 1 second. See here, now you see this completed. It says all dumps can be found in this zip file.
Yep.
It timestamps on this date, this thing, and if you see here, this is the zip file it has generated for me.
So we got that locally, and then
yes, and then they have to figure out a way to send it to you.
Yeah.
Or you can have an FTP server, and then they can upload it, or whatever the mechanism, and then you can now upload it to yCrash, and then you can do the root cause analysis. It's going to be visible for you.
Great.
Okay. Yeah. Okay. So now coming back here, we also give you a kind of a comparison feature. Say suppose you want to compare the reports for a customer. How does it look today? And maybe 2-3 months back they sent another report. So you can do that comparison. You paste that here, and then it's going to compare, and then you will see all the metrics side by side, the GC metrics, thread metrics, network metrics, everything. You can see that together side by side. Okay. So and then we have a very primitive support for the notifications. See, you can configure saying that whenever any incident comes, you can say Say you have a bunch of support engineers supporting your X customers. Another engineer supporting Y customers. They can give that application name, say Netflix is the company, and then you can say Steve, Joe. You can give those email address. Then the emails will be sent only to these parties, not to everyone. And then also in terms of integration, what we have is, we have integration with Jira and also with ServiceNow. So whenever any incident comes in, you can have it configure automatically a Jira ticket to be created, a support ticket to be created. And whenever any incident comes, you can say, you can also integrate with ServiceNow. Automatically a ticket will be created in ServiceNow. Okay. So these kind of integrations are also available for you. Okay. So yeah, so this is all the from a high level that I wanted to talk, and I've shared. Like any questions that you may have, pointed questions, I can take it and answer. Yeah.
You guys have any questions?
No, I don't. I mean, I like the tool. I think the agent we'll have to discuss and see exactly if that would fit for us.
Okay.
But I do like all the other tools. I mean, I use them and they're helpful for me. So I think they'd be helpful for others.
Okay.
It does sound like there is a certain list of features in the yCrash that even if we don't have the agent running, we can manually upload different things. Do we have a list of those, like a non-agent non-agent feature list?
See, when you say non-agent feature list, what you can do is you can analyze. See here, I think this is what you are referring to. So here you can upload the GC log,
right.
thread dump, heap dump, and then here are the other files that we also support. You can do a top-h, disk usage, netstat, vmstat. You can select, when you say analyze, all the data will be analyzed, combined, married, and then you'll get a root cause report to be done.
Gotcha.
So yeah, that would be interesting to be able to gather that data in like one spot, just run one thing.
Correct. Having it in one thing. Yeah, and then the beauty is you can tag them also. Say you want to say tag it by this release. Put a release 4.1 or 10.21, and then say suppose you want to search here, then you can search by the tag. So then you will see all the reports that has happened with the tag. So you can see all the tickets that has happened for a particular release. Dumps, you want to see all the dumps, you can see them here. The search capability gives you that. See one thing, friends, I didn't go deep into the report. See, our reports are very sophisticated. Maybe just.
Yeah, we can look. I'm also interested. So there's that shared license option we're looking at with all three of the tools. I'm curious to see what the difference is in like the manually loaded yCrash report versus that option. Okay.
So I will inform Monica. She's the one who handles these things. So she will get back to you on this.
Okay.
Mike. Yeah. So I'll go a little bit more into the report because we have time. Okay. See, this is a thread dump I'm uploading. So this is if I'm not wrong, this is a problem that happened in a very, very major application. See, what we do is we paint this kind of a transitive dependency graph. Say, if a threads are blocked by other threads, you want to see what threads are blocked by other threads, we do that for you here. We say there is this finalizer thread. This finalizer thread is blocked because of this thread. All these threads are blocked because of this thread. And now, then that means this is the culprit. We try to say in a fairly English what's going on here. And if you want to see the stack trace of this, I'm going to just click here. I'm going to click here. What has happened was, see, you can see there was a bug in the compUAR. compUAR is basically Dynatrace. Dynatrace had a problem. So this customer had installed a new version of Dynatrace agent, And that agent blocked all the database calls which were going in, and they never released the lock. Due to which any threads which was coming behind, they were also getting blocked. And once they took this one and showed it to Dynatrace, then they acknowledged, yeah, this is a problem. And then they installed a new version, then the problem went away. So we paint you this kind of a transitive dependency graph showing all the blocks. And then we also have this kind of a flame graph showing where the tools is say if I just want to click and just see this tower, what's going on. I can see that. And
is this flame graph by CPU or?
No, this is just by the thread stack trace. Just by thread, it shows you what.
Oh, I got you.
Yeah, what line of code and how many threads are working. And I can do a search. Say you want to see the Cassandra here. I can do that. I don't think this is using Cassandra. So say suppose this is using Spring Framework.
Yeah, that flame graph is very interesting. So you can see the different probably executor threads and all their current.
Yeah, I can see all the things highlighted where they are working on. And if you want to see, some people like to see this as a flame graph. Some people like to see this as a call stack tree. So I can, if you want, I can see this as a call stack tree. Like this says me like 2,800 threads were here. Out of the 2,400 threads went here. I can keep drilling it down and keep going. And now coming back, see, there are multiple.
fastThread will do that. Yeah, okay, this is fastThread. Okay,
Yeah.
I see the link. Yeah, great.
Yeah. See, my friend, there is multiple sections here in the fastThread. For some reason, my machine. Okay. See, we also look for multiple things. Say, if we see exceptions in the thread, then we have a separate section to report them. These are all the threads which is experiencing exception at the moment when the problem happened. We look for deadlock. Anything is there. And then let's say you want to do you want to do advanced search. I can do a search here. Say I want to say Spring Framework. Say here I can do a search. You can see how many threads are here and what state they are. I want to do a filtering. I just want to do it by a thread name or thread stack. I want to do a regular expression. I can do all these things. See, what I'm showing you is just the tip of our iceberg of what our tool is capable of doing. We have multiple patterns. We apply those patterns and then we get to the root cause of the problem.
Will that drop down, that search drop down, will it save your history? So say if I have a certain number of search issues that I typically would search for, like in our case, we have something called a tombstone maybe, or something like that. Will this drop down, will it save your search history in that thread search?
No.
Okay.
Right now that thing is not there. The search
Maybe
is
feature requests.
Okay, got it. Yeah. Yes. Just like how they have in Jira and all those things, save the history.
Right.
Yeah.
Sometimes you want to click it and you don't remember like some of the
Correct.
usual suspects, and there they are for you. Yeah.
I agree. Cool. Yeah. So yeah, and then sometimes say suppose you can upload multiple thread dumps together. So you can make it as a one zip file and then upload. You can make it as one zip file and upload, or else the other option is you can upload one thread dump at a time also. See here we have captured like a 2-3 thread dump. Say I can do this, and then I can do this. Yeah, uploading 2 snaps. I can add as many thread dumps, or I can upload one zip file with multiple thread dumps also in it. When I do that, see here it gives me one report per thread dump. I can see 2 thread dump. I also have a comparative summary here coming up. The comparative summary, I can clearly visualize, oh, these are the threads and what states they are in these 2 threads. And then see if the threads are looping in, even we can point them out. These are the suspect threads. And if their threads are continuous blocked states, we report them here. And here's a combined flame graphs. So we do those kind of stuffs also. And let's say you want to download this as a PDF, you can do that. But PDF is not very strong, so it's better to circulate it as a hyperlink to your team members.
Gotcha.
Yeah. Okay.
Awesome.
Okay. Yeah. Yeah.
You guys have any questions?
Yes.
I don't.
Yeah, I think I have some idea about how I'd like to move forward with things. Want to talk about it? So I think we definitely want to get us set up for that concurrent license for one or more machines on our end. And for the YC stuff, do you have is there an option that we could demo this, maybe not send to our customers, but install it locally and play around with it and see how it's going to behave practically for us for some time?
Yes, definitely.
Awesome.
What you can do is just go to the yCrash.io, and then you can say start a free trial.
Oh, great.
So it gives you a 14-day trial key. And if you want more time, you just send an email to our team at tieronapp.com. We can give you extension, trial license extension, not a problem. Yeah.
Okay, very good. I think that's probably what we're going to do, because I definitely am interested in this. It depends on some things, like Steve mentioned, how the agent's going to work and how much buy-in we can get from customers to do that. What the licensing like, all that stuff. So I'm pretty good that we want to move forward with the shared concurrent seats thing.
Okay.
But the yCrash stuff, we definitely want to. I think we're definitely going to do the trial and see how the specifics work. Yeah. But this is a really great presentation. I appreciate it.
Okay. Yeah. Thank you very much, Mike. Thanks a lot.
Anything from you guys?
No, just a good presentation, and I've used the tool before, so definitely looking forward to using it locally.
Okay. So thank you very much. Yeah.
All right. Yeah, I think that's a good path forward. So whoever else can I guess sync up with me in our email about finishing out the engagement for the concurrent seats, and then the specifics on the licensing after our free trial if we do move forward on the yCrash.
Okay.
Great.
Yeah, sounds good.
Awesome.
Definitely, we can. Monica will get back to you on that. Yeah.
Sounds good.
Okay.
All right,
Thank you for your time, Ram.
Yeah, thank you, friends. Thanks a lot. Thanks for taking time to look at it.
You have a good weekend.
Yeah, you too. Bye.
Thank you. Bye-bye.
Bye.